I'll close with a short discussion of ocean acidification. I like it as a component of global change to talk about, because even if you are a hard-bitten global warming skeptic, and I talk to that community fairly often, you cannot deny the simple physics of CO2 dissolving in the ocean. We're pumping out lots of CO2 into the atmosphere from fossil fuels, from cement production. Right now, about a third of that carbon dioxide is dissolving straight into the sea. Right? And as it does so, it makes the ocean more acidic. So you cannot argue with that. That is what's happening right now. And it's a very different issue than the global warming issue. It has many consequences. There's consequences for carbonate organisms. There's many organisms that build their shells out of calcium carbonate, plants and animals both. The main framework material of coral reefs is calcium carbonate. That material is more soluble in acidic fluid. So one of the things we're seeing is organisms are having to spend more metabolic energy to build and maintain their shells. At some point, as this transient, as this CO2 uptake in the ocean continues, that material is actually going to start to dissolve. And on coral reefs, where some of the main framework organisms disappear, we will see a major loss of marine biodiversity. But it's not just the carbonate producers that are affected. There's many physiological processes that are influenced by the acidity of the ocean. So many reactions involving enzymes and proteins are sensitive to the acid content of the ocean. So all of these things, greater metabolic demands, reduced reproductive success, changes in respiration and metabolism, these are things that we have good physiological reasons to expect to see stress caused by this transient. So we've figured out some pretty interesting ways to track CO2 levels in the atmosphere going back millions of years. We used to do it just with ice cores, but in this case, we're going back 20 million years, and we take samples of the sediment, and it tells us the CO2 level of the ocean, and therefore the CO2 level of the atmosphere. And here's the thing. You have to go back about 15 million years to find a time when CO2 levels were about what they are today. You have to go back about 30 million years to find a time when CO2 levels were double what they are today. Now, what that means is that all of the organisms that live in the sea have evolved in this chemostatic ocean with CO2 levels lower than they are today. That's the reason that they're not able to respond or adapt to this rapid acidification that's going on right now. So Charlie Viren came up with this statement last year: the prospect of ocean acidification may well be the most serious of all of the predicted outcomes of anthropogenic CO2 release. And I think that may very well be true. So I'll close with this. We do need the protected areas, absolutely. But for the sake of the oceans, we have to cap or limit CO2 emissions as soon as possible. Thank you very much.